Hello everyone. We're at the next section of the course, Concepts of Graph. A graph is a generalization of a tree. In a tree, every node has one parent. In a graph, a node can have multiple parents. In this section, we will discuss different types of graphs and the ADT graph. We will represent graphs in memory and traverse it. Now we move on to the first video of this section that deals with a graph. In this video, we will look at a graph and different types of graph. We will cover the basics of each. What is a graph? A graph is a collection of vertices and edges that connect the vertices. The figure gives a visual representation of an example of a graph. There are a few features to note here. We will discuss them next. Undirected graph. An undirected graph is a graph in which the edges have no direction. Directed graph. This is a graph in which the edges have a direction. Path. A path is a sequence of edges that connects a set of vertices that are distinct from one another, except the first and the last vertices, as they may be the same. For example, the edges AB, BD and DE represent a path. It can also be described as the ABDE path, which does not repeat its vertices. In the case of a directed graph, the edges must traverse only in the specified direction to form the sequence of edges required to make a path. Cycle. A cycle is a path with at least two vertices involved. It starts and ends on the same vertex. For example, the path DCED is a cycle. Loop. A loop is an edge that connects a node to itself. In the figure, vertex A has a loop. Subgraph. The subgraph of a graph is another type of graph where all the edges and vertices are the same as the edges and vertices of the original graph. For example, in the figure, the nodes A, B and C along with the edges AB and BC represent a subgraph. Connected graph. A connected graph is a graph in which there exists a path that starts from any arbitrary vertex and ends in any arbitrary but different vertex. The graph in the figure here is not connected, but the subgraph with vertices H, I and J and the edges HI, IJ and JH represent a connected subgraph. Tree. A tree is a connected but undirected graph with no cycles and loops. This is an example of a tree. Note that it is slightly different from the tree we have studied earlier. This tree does not have any particular root. The nodes in this tree do not have any particular parent, and any node can act as a root. Forest. A forest is an unconnected, undirected graph with no cycles or loops. You can think of a forest as a collection of trees. A single tree is also a forest. In other words, a forest is a collection of 0 or more trees. Complete graph. A complete graph is an undirected graph that has the maximum number of edges given a certain number of vertices. It also has constraints as per which there can be only one edge between two given vertices with no loops. The figure here shows an example of a complete graph. For a complete graph with the set vertices V and the set of edges E, mod of E is equal to mod of V multiplied by V minus 1 divided by 2. It is easy to see why this is the case. Each vertex will have an edge between itself and other V minus 1 nodes. That makes a total of V multiplied by V minus 1 edges. However, in this approach, each edge is counted twice, once for each of its two vertices. So, the actual number of edges in a complete graph is V multiplied by V minus 1 by 2. So, we understood what a graph is.